Hello guys, hope you're doing well. Let's start with the most basic rule. We know that the derivative of e to the x equals e to the x. So the integral of e to the x dx equals e to the x plus c. It's that simple. But what happens when the exponent isn't just x? What if it's a function like e to the kx? Here we need to use the reverse of the chain rule, which is effectively u substitution. So we have the integral of e to the kx dx equals 1 over k e to the kx plus c, because the derivative of kx equals k. So when you integrate, you divide by the derivative of the exponent. If the exponent is kx, its derivative is k, so we divide by k. For example, the integral of e to the 3x equals the derivative of 3x is 3, so we have 1 over 3 e to the 3x plus c, or the integral of e to the negative 5x equals 1 over negative 5, because the derivative of negative 5x equals negative 5x e to the negative 5x plus c, or the integral of e to the 3x minus 2. The derivative of 3x minus 2 equals 3. So we have 1 over 3 e to the 3x minus 2 plus c. Or the integral of e to the 1 half x minus 1. The derivative of 1 half x minus 1 equals 1 half. So we have 1 over 1 half e to the 1 half x minus 1 plus c. So we have 1 over 1 half equals 2 e to the 1 half x minus 1 plus c, because the derivative of 2e to the 1 half x minus 1 equals, we know that the derivative of e to the u equals u prime e to the u. So we have the derivative of 1 half x minus 1 according to this formula, u prime equals 1 half times 2 times e to the u, e to the 1 half x minus 1. So 1 half times 2 equals 1. So the derivative of 2e to the 1 half x minus 1 equals e to the 1 half x minus 1. E to the 1 half x minus 1. Or the integral of e to the square root of 2x. The derivative of the square root of 2x equals the square root of 2. So we have 1 over the square root of 2 e to the square root of 2x plus c, or the square root of 2 over 2 e to the square root of 2x plus c. Here I've rationalized the fraction to make it easier to work with, right? Next, the integral of 1 plus e to the 2x over e to the x dx. Let's break the fraction apart. So we have 1 over e to the x, the integral of 1 over e to the x plus e to the 2x over e to the x, e to the 2x over e to the x dx. So we have the integral of 1 over e to the x equals e to the negative x. And as you know, e to the 2x equals e to the x times e to the x. So e to the 2x equals e to the x times e to the x over e to the x. So we have e to the x. So plus e to the x dx equals the integral of e to the negative x dx plus the integral of e to the x dx equals the integral of e to the negative x equals 1 over negative 1 e to the negative x plus the integral of e to the x equals e to the x plus c, and final answer equals negative e to the negative x plus e to the x plus c. Things get a little more interesting when the exponent is more complex. Let's look at this one. The integral of x e to the x squared. Here we can't just divide by a constant. We need u substitution. Let u equals x squared. So if we take the derivative of both sides, we get du equals 2x dx, or x dx equals 1/2 du, right? So the integral of x e to the x squared dx equals e to the x squared equals e to the u. So we have the integral of e to the u, and x dx equals 1/2 du times 1/2 du. Now we can take the 1/2 out of the integral. So we have 1/2 the integral of e to the u times du. And we know that 1/2 the integral of e to the u with respect to u equals e to the u plus c, and u equals x squared. So we have equals 1/2 e to the x squared plus c, right? So the integral of x e to the x squared equals 1/2 e to the x squared plus c, or the integral of x squared e to the x cubed dx. Let u equals x cubed. So if we take the derivative of both sides, we have du equals 3x squared dx, or x squared dx equals 1 over 3 du, right? Now we substitute into our integral. We replace x squared dx with 1 over 3 du, and e to the x cubed becomes e to the u. So we have the integral of e to the u times 1 over 3 du, and equals 1 over 3 the integral of e to the u du. So we have 1 over 3 e to the u plus c, and as you know, u equals x cubed. So we have equals 1 over 3 e to the x cubed plus c. The integral of sine of x e to the cosine of x. If we set u equals cosine of x, and if we take the derivative of both sides, we have du equals negative sine of x dx, or sine of x dx equals negative du, right? So we have the integral of e to the cosine of x equals e to the u times sine of x dx equals negative du, and we can take the minus sign out of the integral. So we have negative the integral of e to the u du, and as you know, the integral of e to the u with respect to u equals e to the u plus c, or u equals cosine of x, negative e to the cosine of x plus c. The integral of e to the 1 over x squared dx. This one catches a lot of students off guard. How do we handle the x squared in the denominator? As you know, 1 over x equals x to the power of negative 1. So, the derivative of x to the power of negative 1 equals negative 1 x to the power of negative 2, right? Or negative 1 over x squared. Look at this example. 1 over x squared dx. 1 over x squared dx, right? So, let u equals 1 over x, and if we take the derivative of both sides, we have du equals negative 1 over x squared dx. So 1 over x squared dx equals negative du, right? So we have the integral of e to the 1 over x equals e to the u. E to the u, and 1 over x squared dx equals negative du times negative du. So we have negative e to the u du, and we know that the integral of e to the u with respect to u equals e to the u, or negative e to the 1 over x plus c. This example is very important. The integral of a to the x dx. The integral of a to the x dx equals a to the x over ln of a plus c. For example, the integral of 3 to the x dx equals 3 to the x over ln of a plus c. That's it. It's very simple. Or the integral of 5 to the x dx equals 5 to the x over ln of 5 plus c. Or the integral of 7 to the x equals 7 to the x over ln of 7 plus c.